Here recently, the folks over at 52pi.com reached out and asked if they could send me a mini tower NAS kit for me to review here on the channel. I told them that the case looked great, but I couldn't just review a Raspberry Pi case here on the channel. However, if they wanted to include a Pi 4 to go in it, I could probably make some content that included the Raspberry Pi 4 case that they wanted to send over. They agreed and sent over the mini NAS tower kit, as well as a 4 gig Raspberry Pi 4. A few days ago, I made a short where I put it together to prep for the video that you're watching now. And as I mentioned in this short, the case only took about 20 minutes to put together, even with recording and that sort of thing going on. Something to keep in mind with this case is that it does support M.2 drives, just not NVMe M.2 drives. You need to use a SATA M.2 drive for this setup. Now I've got a 512 gig 2280 M.2 drive that I had just laying around from another project. That's what I'm using in this case, along with a 256 gig USB thumb drive that we're going to use for the operating system. Also, as per usual, links to everything, the resources that I used, the parts that I used, all of that will be available in the description down below if you'd like to pick everything up and follow along with this the way I'm building it. So with all of that out of the way, let's get started getting OpenMediaVault 6 set up on our new Raspberry Pi 4 kit. So to get started, of course, the first thing you're going to want to do is download Raspberry Pi Imager. Of course, like I said, links to everything will be available in the description down below. Next, you want to plug in your USB boot drive or your micro SD card, whatever the case is. Select Raspberry Pi OS Lite 64-bit, and then flash the drive using Raspberry Pi Imager. At this point, you can plug in your newly flashed boot drive into the Raspberry Pi, also plug in a monitor and keyboard, and then go ahead and plug in the network cable as well as the power cable so that it can boot up for the first time. If everything goes well, you should then start to go through the process of installing the Raspberry Pi Lite OS on your Raspberry Pi. Just follow all of the prompts that are available as you're kind of going through that process. I'll show what I did here, but just do the stuff that's relevant to you. And then once that's done, we should be good to go. So of course, just like any other new operating system, once it's first installed, there will be updates. So go ahead and run the update and upgrade script. Once the updates are done, the next thing you're going to want to do is enable a couple of different features using raspi config in the terminal there in the command prompt that you've already got open. So just type in sudo or sudo, however you want to pronounce that, space raspi-config, and then go into your interface options and enable the SSH server. And then because we're using this case and it needs I2C in order to make certain things work, we're going to go ahead and enable that as well. Now, if you're not using this case or a case like it, you don't necessarily need to enable I2C, but for the sake of this case, we're going to go ahead and get it enabled. Once you've got the SSH server enabled and you've got I2C enabled, if it pertains to you anyway, the next thing I like to do is get the IP address of the Raspberry Pi. Now, the reason I like to get the IP address is so that I can go back to my main system and SSH into it and then just copy and paste the commands that I'm going to need in order to get the rest of this stuff taken care of. So to get the IP address while you're still on that system, open up the terminal, which you're probably already at, and just type in IP space ADDR, and then you should get something like 192.168.0. something, or 192.168.1. something, or 10.0. Like there's lots of different combinations out there, but you're looking for the IP address of your Raspberry Pi. Store that, keep that in mind so that we can go back over to our main system, open a command prompt, and then go ahead and SSH into it. It's just easier, in my experience, to do this via remote SSH. So now you can go over to another computer and SSH into the Pi using the IP address and the username and password that you created during this setup. Again, as I mentioned, doing it this way just makes it easier to copy and paste commands over to the Pi rather than trying to do it on the Pi. So the next step, once you've got everything updated and all of this stuff enabled, you're going to run the OpenMediaVault installation script. Again, all of this will be available in the description down below. This will take several minutes. For my setup, my internet, my device, all of that took me about 12 minutes to fully install. So this little section of the video is specific to this case. So if you're not using this case, just head down to the timestamp that skips this, or you can watch it if you want. It's just not going to be relevant to your setup. So if you'd like to skip that, there will be a timestamp down below so that you can skip this section and get right back into setting up OpenMediaVault 6 on your Raspberry Pi 4. At this point, OpenMediaVault 6 is installed, but let's install a couple of scripts to get the full features of this case enabled. So after a fresh install of an operating system and all of the updates and that sort of thing, the first thing I like to do is just reboot my system to make sure that everything takes effect appropriately. So in order to get the most functionality out of our case and allow our Raspberry Pi to communicate with the case hardware, the LED or the OLED screen, as well as the fan, what we need to do is actually install the I2C tools per the instructions over on the wiki at 52pi.com. What we do need to do is change one little part of that script that they've got. They use the username Pi. We need to change that to whatever the username is that we used when we set up our operating system at the beginning. So in order to get the full functionality out of our case, we will need to clone a couple of GitHub repositories over to our device. But first, we need to install Git on our device. So we're just going to go to the terminal. We're going to SSH in. We're going to type in sudo apt install Git, and that will install Git on our system so that we can then clone GeekPi's ABS Mini Tower Kit repository. Once you've got that cloned, you can cd into ABS Mini Tower Kit and then run the sudo./install.sh to install the fan software. Once the fan is running and all of the scripts have completed, you can then run sudo sync and sudo reboot to make sure that everything takes effect. And then again, we're going to jump right back into the terminal via SSH and clone another repository to get the LCD screen to work. So once you are reconnected via SSH to your newly rebooted Raspberry Pi, we're going to run git clone rm-hole/luma.examples.git. And that will then clone that repository over to our device. We'll change directories into that newly created folder. And then we're going to install the script via running sudo-h pip3 install e period. Once that's done, you can then cd into the example folder and see the different options available on the screen by default. We're going to go ahead and look at a couple of different options. The first one will be sysinfo and then the Space Invaders theme, and you can use Control-C to stop those at any time. Once you found the example that you want to use, you can cd into lib/systemd/system, and then you're going to use sudo nano mini tower _ OLED.service, and then modify the exec start line to use the .py example you want on your screen. Then you can do Control O and then Control X to save and exit. Then you're going to run a couple of more commands to make sure that everything kicks in the way we want them to by running sudo systemctl daemon reload, and then once that's done, sudo systemctl restart mini tower _ OLED.service, and then at that point, whichever screensaver you picked for your screen should stay up anytime the device is powered on. So now we're going to jump back into the OpenMediaVault 6 setup process, kind of to finish out that part of what we're doing here. In order to get Docker and Portainer and Yacht access in OpenMediaVault 6, we need to install OpenMediaVault 6 Extras, or OMV Extras. So what we're going to want to do is actually SSH into our Raspberry Pi again. Then we're going to run the command sudo su, and basically what that's going to do is just kind of give us root access to run things without kind of having to do a lot of unnecessary extra commands and that sort of thing. So just sudo su will give us the root access that we need for the next steps. Once you've got sudo su up and going, which will it will give you a different looking command prompt. Once that has taken effect or kicked in or whatever, you're just going to go ahead and run the OpenMediaVault Extras script to get it to install all of those different features for our setup. So once you have got the OMV Extras installed, it may not be a bad idea to just go ahead and reboot the system just to make sure that everything takes effect properly. At this point, OpenMediaVault 6 is installed and OMV Extras is also installed. So what we want to do is head over to our browser and open a new tab, if we don't already have one open, and type in the IP address of our Raspberry Pi. That's going to bring us over to obviously our OpenMediaVault 6 login screen, and we're going to get logged in with the username of admin and the password of OpenMediaVault. Everything is lowercase. Go ahead and type those in, click login, and you're going to be brought to a fairly blank dashboard. Once you're logged in, go to System in the left column and then click OMV Extras. Click Docker and you'll see that the status is not installed. Click the install button at the bottom of the screen and wait until the modal window says end of line. At that point, you'll know that everything has completed and you're good to go with that. Now you can go back and repeat those same steps to install portainer, or if you wanted to, you could also do that with Yacht. One or the other, both, however you want to handle it. Just know that you may have to change some ports if you decide to use both portainer and Yacht. So you may just want to pick one or the other and stick with that. Next, we want to go ahead and mount our data drive so that we can actually have enough space to install the Docker containers and that sort of thing that we want to run on our machine. So what we're going to do is go back over to our dashboard and click Storage, and then click Disks, and make sure that your drive is showing up. If your drive is there, you can click on File Systems, and then on the next system, you can select your drive and click Save. After a moment, the drive should show up, but it may already have a different file system on it that may not work. Mine showed up as NTFS. I want ext4, so I'm going to go back and wipe the drive and then recreate the file system. So I'm going to go back to storage and then click on disks and then click the drive that I want to wipe. Don't wipe the OS drive. I shouldn't have to say that, but I'm gonna. Then click the eraser icon and click yes. After a moment, the process will complete, and then you can go back to storage and file systems and select your drive. Click on the plus icon, click create, select your data drive, and make sure that the file system is set to the file system you want. I'm going to choose ext4 and click save. This will take some time depending on the size of your drive. Mine took about 7 minutes to complete this 512 gig drive, but once it's done, it will say end of line at the bottom, and you can click the close button. So now that we've created our file system, we need to mount that file system. And to do that, we're going to go to Storage and then File Systems, click the plus button and select the file system that we just created. Make sure that you're good with the warning threshold number and enter a comment. I entered storage on mine just so that it's easier to remember later. Click the Save button and wait for it to complete, and then click the Save button in the yellow bar that pops up at the top of the screen to make sure that those changes take effect. Now we need to enable SMB/CIFS. So we're going to go to Services and then SMB/CIFS. We're going to click or check the box that says Enabled and then click Save. Again, once that's done, click the Save in the yellow bar that pops up at the top, again, to make sure that those changes take effect. So now we're going to create some shares for our setup here. I usually create a couple, but in this case, I'm just going to create one called Docker. So we're going to click Storage and then Shared Folders. We're going to click the plus button and then enter a share name and a file system. Set the permissions to what you want for your setup. I use everyone read and write because I'm the only person on my system who's going to be doing anything. But you may want to restrict that if you're going to have multiple users, or if I'm being honest, if you'd like to have a more secure setup. You can repeat this process as many times as you need to for as many different shares as you want, and just remember that you can always go back and add more shares later. Now, in order for these new shares that we just created to be available on the network, we need to share the shares in the system. So what we're going to do is go to Services, SMB/CIFS, Shares. We'll click the plus button and then we'll click Enabled and select a share in the dropdown. I set my shares to public again because I'm the only person on my system, but you may want to restrict this a little bit again depending on your requirements. You can also enable the features and settings that you want. Click Save and again repeat this process for as many shares as you have available. Of course, you can always go back and add more to this later. Once you've got all of that done, again, be sure to click the Save button that's in the yellow bar at the top of the screen to make sure that all of these new changes do take effect. At this point, we should be able to access our shares anywhere on the network. If I open up a Windows Explorer window and go to the IP address of my Raspberry Pi, I can now see the different shares that are available to me, as well as being able to create files in them as I show here. So now we want to take a look at accessing Portainer for the first time. You're going to open another browser window or tab and go to your Raspberry Pi's IP address with port 9000 tacked onto the end of that IP address. At this point, if you've waited too long and you've gone through all of these other steps, you may run into an issue or an error message saying that Portainer needs to be restarted. To quickly restart Portainer, open up a terminal window, SSH into your Pi, and then just type in docker restart Portainer. Give it a second, and then it will automatically restart Portainer. Once Portainer has restarted, you can then go back over to your browser to your IP address, port 9000, and then you'll be prompted to create a new username and password. Don't use admin for your your username. Your password needs to be at least 12 characters long. Once you've entered your username and password, click on Create User. You'll be automatically logged in and you can click Get Started. Now, one of the things that I almost always forget to do when I set up a new portainer instance is to set the IP address of my server in the environments. So what you want to do is click on Environments in the bottom left-hand area under Settings, and then click Local. On that screen, enter your server's IP address in the box labeled Public IP, and then click Update Environment. So at this point, our Raspberry Pi server is basically set up and ready to go, at least at a basic level. We can use it as a NAS, and we can use it as a Docker server, but we need to be careful about the Docker images that we try to deploy on our server because we have an ARM processor, and that's going to limit us a little bit. So if we come over to hub.docker.com, we're looking at Linux servers WireGuard container, and I did this on purpose. Really, Linux servers are really good about making sure that all of their containers are compatible with ARM processors. And the way you can find out is if you go to a page with any container on this site and look at their tags, you can see that this one says Linux/AMD 64. That means it's going to be compatible with Intel and AMD processors, desktop style processors. That's kind of what's going on with that Linux/AMD 64 line. However, below that, we've got ARM v7 and ARM 64 v8 there as well. That means that this container is compatible with both desktop and ARM processor or Raspberry Pi devices. However, as another example, if we look at OpenStax/recipes, this is just an example, and we look at their tags, this one just says Linux AMD 64. Nowhere on there does it mention ARM, which tells us that this isn't compatible, and this will throw an error and tell us that it's not compatible. It's going to use some tech lingo, but basically it's going to tell us that this isn't compatible. So if you're trying to deploy a container on a Raspberry Pi Docker server, make sure that when you go and you look at the image or the latest or the tags or whatever, that it says ARM/v7 or ARM64/v8. That will help guarantee that the container you're trying to deploy on your Raspberry Pi server will be compatible. So guys, there you go. There's how to set up OpenMediaVault 6 on a Raspberry Pi 4. I want to give a big shout out to the folks at 52pi.com for sending me the case as well as the Raspberry Pi 4 that we used in this video. Of course, as per usual, everything will be linked in the description, including all of the resources that I used online as well as the hardware. All of that will be available in the description if you want to go check that out. Also, while you're down there, you can find a couple of different ways to support the channel if you want to do that. A couple of those ways, whether it's being a channel member, a patron, or joining dbtech.fans, will give you access to my content with 0 ads. That's no baked-in ads. That's no YouTube ads, nothing like that. And you can get access to my ad-free content for really as little as $1 a month. And I want to thank the few people who have actually joined at that $1 level to help prove my point. So thank you guys so much for spending a few minutes of your day with me today. I really do appreciate your time, and I will talk to you in the next video.